Hello everyone. Thank you for tuning into AI in the New Era conference. My name is Manoj Aggarwal and today I want to talk to you about something that's simultaneously one of the most exciting and most concerning developments in financial technology. Agentic AI and payments. When I say agentic AI, I'm talking about AI systems that don't just make recommendations. They take action. They autonomously decide whether to approve a transaction, block a payment, flag potential fraud, or route money through complex financial networks. And they do this thousands, sometimes millions of times per day. The title of this presentation is Powerful, Dangerous, and Inevitable. And I chose those words carefully. Agentic AI is powerful because it can process transactions at speeds and scales humans simply cannot match. It's dangerous because when it makes mistakes in the payments domain, real money is lost, real customers are hurt, and real trust is destroyed. And it's inevitable because the competitive pressures, the volume of transactions, and the sophistication of fraud have reached a point where human only oversight is simply no longer viable. Today, I'll address two critical questions. First, why is deploying agentic AI in payments so uniquely challenging? And how do we balance the autonomy these systems need with the risk mitigation that our customers and regulators demand? And second, what practical mechanisms can we implement to ensure that these AI agents operate safely and effectively in one of the highest stakes environments imaginable? Let's dive in. There is a paradox at the heart of agentic AI in payments. The very characteristic that makes these systems valuable, their autonomy, is the same characteristic that makes them risky. Think about it. We deploy AI agents because they can make decisions faster than humans, process more data than humans, and identify patterns that humans would just miss. But the speed and autonomy means that when things go wrong, they go wrong very, very quickly. A misconfigured fraud detection agent can block thousands of legitimate customers in minutes. An overly aggressive revenue optimization agent might approve fraudulent transactions to hit performance goals. The damage can be immediate and severe. This is totally different from deploying AI in many other domains. If a recommendation algorithm on a streaming service makes a mistake, a user just sees a bad movie suggestion, annoying but not catastrophic. If an agentic AI in payments make a mistake, someone might not be able to buy groceries, a business might lose a critical sale, or a fraudster might steal thousands of dollars. Let me break down why deploying agentic AI in payments is particularly difficult compared to other domains. First, it's about immediacy and finality. Payment decisions often need to be made in milliseconds. When someone swipes their credit card at a checkout counter or clicks buy now online, they expect an instant response. There's no time for lengthy analysis or committee deliberation. The AI must decide, approve or decline right now. And once that decision is made, especially once money has moved, reversing it is complex, it's costly, and it's sometimes just impossible. Second is about high stakes with every transaction. In payments, every single transaction carries real financial risk. Unlike systems where errors can be averaged out over many decisions, every payment is a high value decision for someone. A false positive that blocks a $20 transaction might seem small to the system, but it could just prevent someone from buying their child's medication. Scale that across thousands of customers, and you have created a crisis. Third is the adversarial environment. Payments operate in an explicitly adversarial context. Fraudsters are constantly evolving their tactics, specifically trying to fool our AI systems. This isn't just a benign environment where we are just trying to optimize for efficiency. We are in an arms race. Our AI agents aren't just processing transactions, they are actively being attacked by sophisticated criminals who study their behavior and exploit their weaknesses. Next is about regulator scrutiny. The payment industry is one of the most heavily regulated sectors. We have to comply with anti money laundering regulations, know your customer requirements, GDPR data privacy laws, and certain industry specific standards. When we deploy an AI agent, we just don't need it to work. We need it to be able to explain its decisions to regulators. The AI said so is not an acceptable answer when financial crimes enforcement network comes calling. The last is about the trust equation. Payment systems run on trust. Customers trust that their legitimate transactions will be approved. Merchants trust that they'll be protected from fraud. Banks trust that the system won't expose them to unacceptable risk. Agentic AI can optimize many things, but if it undermines trust, it destroys the very foundation of payment system. Now let's talk about the three interconnected risks that define the challenge of agentic AI in payments: false positives, revenue loss, and fraud. I call this the triad of risk because these challenges are deeply intertwined, and solving one often makes the others worse. Let's talk about false positives first. These are legitimate transactions that the AI incorrectly blocks or flags as fraudulent. Every false positive is a failure of customer service. Imagine you're traveling, you try to pay for a hotel. Your card is declined. You're standing at the front desk, embarrassed, frustrated, and now you have to call your bank. That's a false positive. The AI was trying to protect you, but instead it created a terrible customer experience. But here's the insidious part: false positives just don't annoy customers, they train them to distrust the system. After a few false declines, customers start to think, this card is unreliable, I probably need a backup. Or worse, they switch to a competitor. The lifetime value of a customer can be tens of thousands of dollars. Lose enough customers to false positives, and you have created a massive revenue loss, even if you have successfully stopped some negligible fraud. The next is revenue loss. This comes from multiple sources. Direct revenue loss happens when false positives block legitimate high value transactions. Indirect revenue loss occurs when merchants bear the cost of customer service calls, transaction retry fees, or when they even lose sales entirely because customers gave up. There's also the opportunity cost. Every dollar spent investigating false positives is a dollar not spent on growth or innovation. Here's where the AI deployment gets a little bit tricky. You could reduce false positives by making your fraud detection less aggressive, but then you increase fraud losses. You could optimize purely for revenue by approving more transactions, but then you're giving fraudsters a field day. Every parameter you adjust creates a trade off. Last, let's talk about fraud. On the other side of the equation is actual fraud: criminals using stolen credentials, synthetic identities, or sophisticated attacks to just steal money. Fraud directly destroys value. It creates chargebacks, regulatory penalties, and reputational damage. And modern fraud is increasingly AI powered itself. Fraudsters use machine learning to identify patterns in fraud detection systems. They use bots to test stolen cards at scale, and they use social engineering assisted by AI to manipulate victims. The challenge is that fraud patterns constantly evolve. What worked yesterday might not work today. Your AI agent needs to be adaptive, but adaptation requires autonomy, and autonomy without proper guardrails leads back to the false positives and revenue loss again. So, how do we balance these competing priorities? This is where the art and science of deploying agentic AI converge. The goal is to harness AI's speed and pattern recognition capabilities without compromising financial security or user trust. We need systems that can make thousands of accurate decisions per second while also remaining accountable, safe, and explainable. This requires us to think beyond just the AI model itself. We need to design the entire system, the architecture, the workflows, the oversight mechanisms, and the feedback loops with safety and effectiveness built in from ground up. Which brings me to the second part of our discussion: the practical mechanisms that make safe agentic AI deployment possible. There are three primary mechanisms I want to discuss today: human in the loop workflows, monitoring and recommendation guardrails, and constrained agent designs. Each play a critical role, and the most effective deployments use all three in concert. Let's talk about the first mechanism: human in the loop. These are what I consider as the essential foundation of safe agentic AI in payments. The core principle of human in the loop is simple: AI handles what AI does best, and humans handle what humans do best. But the implementation is far from simple. Here's how a well defined human in the loop system works in practice. The first step is anomaly detection. The AI agent continuously monitors transactions, looking for patterns that deviate from normal behavior. Maybe it's a customer who usually spends $50 per transaction, suddenly making a $5,000 purchase. Or it's a transaction from a device that's never been associated with the account. Or it's a velocity pattern, 10 transactions in 10 minutes when a customer normally makes one transaction a day. The AI doesn't just look at simple rules, it uses sophisticated machine learning models trained on millions of historical transactions. It considers hundreds of features simultaneously: transaction amount, merchant category, geographic location, device fingerprint, time of day, purchase history, and much, much more. It identifies anomalies that no single human could spot. The second step is human review. When AI flags a transaction as potentially fraudulent, it doesn't automatically block it, at least not for high value or ambiguous cases. Instead, it routes the transaction to a human expert for review. This is where domain expertise becomes crucial. A skilled fraud analyst doesn't just look at the transaction in isolation, they understand context. They know that someone buying plane tickets and then making purchases in a foreign country isn't necessarily fraud. It's probably someone on vacation. They know that unusual purchasing pattern around the holidays are probably normal. They can just call the customer directly if needed. The human here provides judgment, empathy, and contextual understanding the AI still struggles with. And critically, they can make the call when the stakes are the highest and the evidence are ambiguous. The next step is system learning. Here's where human in the loop becomes truly powerful. Every decision the human makes becomes training data for the AI. When a human reviewer says this is fraud or this is legitimate, the AI learns from that decision, it refines its models, adjusts its thresholds, and becomes more accurate over time. This creates a sort of a victorious cycle. The AI gets better at identifying clear cut cases, which means fewer transactions need human review. Human analysts can focus on the truly complex cases, where their expertise adds the most value. And the entire system becomes much more accurate, reducing both false positives and false negatives. But human in the loop isn't just about fraud detection, it applies across many payment scenarios. When an AI agent recommends changing a credit limit, a human reviews it. When an AI agent suggests routing a payment through a particular network, a human can override it if they spot risks that the AI missed. When an AI identifies a potential money laundering pattern, a human investigates and files a suspicious activity report. Let's talk about the challenges of human in the loop as well. Of course, these systems are not perfect. These human in the loop systems, they introduce latency, human reviews take time, which can delay transactions. They're expensive, you need skilled analysts, and skilled analysts cost money. And they can also create bottlenecks. If your AI is flagging too many transactions for review, you overwhelm your human reviewers and the system breaks down entirely. This is why the calibration of human in the loop systems is so critical. You want the AI to be autonomous enough that it can handle the vast majority of transactions without human intervention, but conservative enough that it routes truly risky or ambiguous cases to humans. Finding that balance is an ongoing process of optimization. The second mechanism that I want to talk about is monitoring and recommendation guardrails. While human in the loop focuses on decision points, monitoring and guardrails provide continuous oversight of AI agent behavior. Think of guardrails as the lane markers on a highway. They don't tell you exactly where to drive, but they keep you from veering off the road. In agentic AI systems, guardrails are predefined boundaries that constrain AI behavior. Let's talk about performance thresholds. We establish clear metrics that the AI must maintain. For example, the false positive rate must stay below 2%. Transaction processing time must remain under 300 milliseconds for 99.9% of transactions. The fraud detection rate must stay above 95% for non-fraud patterns. When the AI's performance start to drift towards these thresholds, alerts fire. This gives us early warning that something might be wrong. Maybe the model is degrading, maybe fraud patterns are shifting, maybe there's a bug in the system. We can also implement security protocols. We build in compliance checkpoints that the AI cannot bypass. Before approving a transaction, the AI must verify that it meets regulatory requirements. It must check sanctions list, it must comply with data privacy laws. These aren't just suggestions, they are hard constraints. The AI literally cannot approve a transaction that would violate these rules. And if it tries, the system logs the attempt and escalates to human oversight. We can also implement alerting systems. We deploy sophisticated monitoring that watches for unusual patterns in the AI's behavior itself. Is the AI suddenly approving a lot of high risk transactions? Is its confidence score distribution changing? Is it making decisions faster or slower than usual? These meta level monitors help us catch problems with the AI agent because they cause significant harm. Maybe there's a data poisoning attack where fraudsters are just trying to manipulate the AI's training data. Maybe there's a software bug that's affecting decision making. Maybe there's an adversarial attack specifically designed to fool our models. Next, we need to also build real time dashboards. All of this monitoring feeds into real time dashboards that give human operators visibility into AI agent behavior. We can see not just individual decisions, but patterns across thousands or millions of decisions. We can compare current behavior to historical baselines. We can identify anomalies in the AI's own behavior. This is crucial because in high stake environments like payments, we can't wait for quarterly reviews to discuss that our AI has gone off the rails. We need to know immediately. We can also build recommendation systems. An interesting middle ground would be between full autonomy and human in the loop systems. Instead of AI making the final decisions, it recommends actions that humans then just approve with a single click. For routine cases, this is nearly as fast as full autonomy, but it keeps human in the loops and maintains accountability. And the recommendation system can be tuned differently than a full autonomous system. It can be more aggressive in its suggestions because there's still a human checkpoint. The third mechanism I want to talk about is constrained agent designs. The most proactive approach to safe AI deployment is building safety directly into the agent's architecture. This is what I call constrained agent design, and it's about making it structurally impossible for the AI to cause certain kinds of harm. We can limit the scope. Instead of building one super intelligent agent that handles all the payments and all the decisions, we build specialized multiple agents, each with a narrow domain. One agent only handles fraud detection for card not present transactions, for example, under $100. Another agent only handles fraud detection for in-person transactions at gas stations. The third agent only handles velocity checks for wire transfers. By limiting scope, we limit potential damage. If the gas station agent malfunctions, it only affects gas station transactions. We can shut it down, fix it, redeploy without disrupting the entire payment system. This also makes the agents easier to understand and audit. A narrowly scoped agent is more interpretable. We can more easily explain why it made a particular decision because we are not trying to account for enormous decision space. We can also implement principle-based rules. We embed fundamental constraints directly into the agent's decision-making logic. These aren't learned patterns. They are hard rules that the AI just cannot violate. For example, never approve a transaction that would exceed the account's available balance, never process a payment to a sanctioned entity, never share customer data outside of approved systems. These principles act as a safety net. Even if the AI's learned models somehow fail, these fundamental rules ensure a baseline level of security. Let's talk about access controls as well. We can implement granular permissions that limit what each AI agent can do. A fraud detection agent can flag transactions and recommend blocks, but it cannot access customer PII information beyond what's necessary for its specific task. It cannot modify account balances, for example. It cannot change transaction routing. This is the principle of least privilege applied to AI. Each AI agent has exactly the permission it needs to do its job and no more. This limits the blast radius if an agent is compromised or malfunctions. There could be layered decision making. For high stakes decisions, we implement multiple layers of AI agents that must agree. Think of it like a multi-signature wallet in cryptocurrency. Let's take an example. To approve a large wire transfer, you might need a fraud scoring system to verify the transaction looks legit, a compliance agent to verify regulatory requirements are met, a risk assessment agent to verify the bank's exposure is acceptable, and a customer behavior agent to verify this is consistent with the customer's behavior. Only if all these four agents approve does the transaction go through. If any agent dissents, the transaction is now escalated to human review. This creates resiliency. We can also implement rollback mechanisms. We design systems with the ability to quickly reverse AI decisions if needed. This might mean holding funds in escrow for a period before final settlement, maintaining decision logs that are detailed enough that enable retroactive analysis, or we build in automatic reversal triggers if certain conditions are detected. We can also implement safe modes. Every AI agent should have a safe mode, a degraded but ultra conservative operating mode that it cannot fall back to if it detects anomalies in its own performance or in the environment. For example, if the fraud detection agent notices that the pattern of incoming transactions has suddenly shifted dramatically compared to historical norms, it might automatically enter safe mode. In this safe mode, it becomes much more conservative, flagging more transactions for human review, reducing its confidence threshold, and generally erring on the side of caution until the anomaly is explained. Now, the critical point, these mechanisms don't work in isolation. The most effective deployments integrate all these three approaches. You use constraint agent designs to build safely in from the ground up, and then you layer on the top the monitoring and business guardrails to provide continuous oversight, and then you implement human in the loop workflows at critical decision points where human judgment is irreplaceable. This defense in depth strategy means that if one mechanism fails, others often catch the problem. No single point of failure. Let me return to the word in our title, inevitable. Agentic AI in payments is inevitable for several reasons. The sheer volume of transactions has outgrown human capacity for oversight. Global payment volumes are in the hundreds of billions of transactions per year and growing. We simply cannot hire enough humans to review each one. Second, the sophistication of fraud requires AI level responses. Fraudsters are just using AI to attack our systems. Fighting AI with human only defenses is like bringing a knife to a gunfight. The third is customer expectations is also demanding speed. People expect instant everything, instant payments, instant approvals. The latency introduced by human review for every transaction is simply just not acceptable. And fourth is competitive pressure. If your competitors are using agentic AI to reduce costs, improve accuracy, provide better customer experience, you have to use it or you'll be left behind. So the question isn't whether we'll deploy agentic AI in payments. The question is whether we'll deploy it responsibly. We have to build trust through responsible innovation. Trust is the currency of the financial system, and trust in AI is earned through demonstrated safety, transparency, and accountability as well. We build trust by being transparent about how our AI systems work, not giving away PII secrets, but explaining our general approach to the customers and regulators as well. We build trust by being accountable when things go wrong, by acknowledging failures, compensating affected customers, and demonstrating that we have learned and improved. We also build trust by showing that we prioritize safety over short term profits, that we implement guardrails even when they reduce efficiency, maintaining human oversight even when it costs more, and designing conservatively even when it means slower deployment. Finally, remember that deploying agentic AI is not a one time project, it's a continuous process. Fraud patterns evolve, regulations change, customer expectations shift, technology advances. Your AI systems, your monitoring mechanisms, your human in the loop workflows, and your constraint designs all need to evolve continuously. This requires dedicated teams, ongoing investment, and a culture that values both innovation and safety. To conclude, Agentic AI in payments is powerful. It can process transactions at unprecedented scale and speed. It can detect fraud that humans would just miss and optimize for outcomes in ways that create real value. It's dangerous because the autonomy that makes it powerful also creates risk of false positives. We can have revenue loss, you can have fraud and trust erosion if not managed carefully. And it's inevitable. The volume, velocity, and complexity of modern payments demand AI level capabilities. But inevitability doesn't mean uncontrollable. Through thoughtful design, robust oversight, and a commitment to continuous improvement, we can harness the power of agentic AI while mitigating its risks. We can build payment systems that are faster, more secure, more trustworthy than what we have today. We can even create better customer experiences, better protection for businesses, and better defenses against fraud. But only if we approach this technology with both ambition and humility. Ambition to innovate and push boundaries, but humility to acknowledge risk and build in safeguards. The future of payments will be shaped by agentic AI. I have no doubt about it. Thank you.